Hello, everyone. Hello, grade 11 physical science learners. Welcome to our EduBlush presentation on electrostatics. Right? Uh, Electrostatics is a very familiar topic to us as grade 11 physical science learners. For we have done a part of it in grade 10, and we have learned about charges, and that between two charges there is a force that exists, and that force is known as electrostatic force. And we have been also doing some calculations on uh, calculating the new charge when you bring two charges together and you separate them. You realize that they will be carrying equal charge, right? Because when you bring two charges together, they always share the charge. Actually, electrons are transferred from the more negative charge to the less negative charge. So this is electrostatics. And now in grade 11, we are going to be introduced to what we call Coulomb's Law, where we are going to learn to calculate the magnitude of the electrostatic force between two charges. So our topic is electrostatics, right? Electrostatics. So you can see there, electrostatics. I underlined the topic, right? Now, what is it that we need to know just as a recap so that we can pick up on our lesson together? We need to remember, friends, that like charges repel each other while unlike charges they attract. I think those are bullets or points that keep we need to keep up front so that we move together. So let's just remind each other of the obvious basics of our topic. So I'm saying uh, like charges repel each other. Like charges repel each other. So what it means is if you take a positive charge and a positive charge. By the way, like means the same. So if you take a positive and a positive, they repel each other, right? The same if you take a negative and a negative, they repel. To repel is to push each other away. So like charges or similar charges, they repel each other. They push each other away. So what this means is, as we are going to be doing our calculations, as you calculate electrostatic force between two charges, you must always remember that if the two charges were similar, then that electrostatic force is repulsive, right? It means the two charges are going to repel each other or push each other away, right? Then, second bullet, unlike charges attract each other. Unlike means not the same. So it is actually the opposite. Unlike charges attract each other. That is very interesting, right? So it means if you have got a positive charge, you bring it close to another charge which is of the opposite, which is negative. These two, they have a tendency of attracting each other, right? The third bullet that I want to give you before I introduce a Coulomb's law, the third bullet, it says if the charges are at rest, then the force between them is known as the electrostatic force, right? So if the charges um, are at rest, if the charges are at rest, I think we need to underline the term at rest. It means they are not moving, right? So if the charges are at rest, then then the force between them, the force between them is known as the electrostatic force. Is known as the electrostatic force. Allow me to underline the term electrostatic force, right, and put a full stop there. So what it means is we are going to study charges which are at a point. In other words, we are saying charges which are not moving, which are resting. And we are saying the force that exists between those two charges which are at a point is known as electrostatic force. Number one. Number two, we also need to appreciate the fact that electrostatic force is a non-contact force. There is no need for us to put the two charges together or for them to be in contact for this force to exist. As long as you put them close to each other within their electric fields, then they can exert a force on each other, which is either repulsive or attractive. So that force is what we call electrostatic force, and it's a non-contact force. Now, there's a guy called Charles Augustin de Coulomb around 1784. He's the guy who did much work on studying the force of attraction or the force of repulsion between charges, which we are terming electrostatic force. So he published his theory, which later on became the Coulomb's law. And so the Coulomb's law also gives us a formula that we are going to use to calculate the electrostatic force between any two charged objects or between two charges. So I think we need a bit of some history so that we all appreciate our topic and we all appreciate where we are going and where we are coming from, right? So the electrostatic force, I'm just going to give you a brief history of where we get the Coulomb's law from. So the electrostatic, the electrostatic force was first. It was first, right? It was first studied by, right? Studied by Charles Augustin de Coulomb. It's very important that we honor this guy because of the work that he did in the field of physics, Augustin de Coulomb. So you'll appreciate that Coulomb's law actually is named after this guy. So de Coulomb around 1784. Around 1784. You see, it's been a long time. These guys were already studying HIGs and the force that exists between two charges, right? Now let's move on to the law, what he published or what he published as the Coulomb's law. What does it say? And from the law, we are going to get the formula that we are going to use to calculate the magnitude of the electrostatic force between any two charges. Right. What was his findings? Right. So this guy, his findings are he realized that there are two factors which influence the electrostatic force. Right? I think I need to capture this. Let me say there are two factors that influence electrostatic force, that influence the electrostatic force. There are two factors. Now you can start to guess that. So factor number one, it is the magnitude, which is the size, the magnitude of the charges. How big is the charge? How small is the charge? That has a bearing on the ultimate electrostatic force between those two charges. So this guy he discovered that the electrostatic force between 2-point charges, right, is directly proportional to the product of the two charges, which means if we take the charge as our independent variable and force as our dependent variable, it means when we increase the magnitude of a charge, we also increase the magnitude of the force. So we can write it we can build a relationship which says the electrostatic force is directly proportional to the product of the two charges. So that's the relationship that we are getting from there. The electrostatic force is directly proportional to the product of the two charges. What it means is if we can increase either charge 1 or charge 2, or if we increase both, it means the force also increases. So we say they are directly proportional. Is that fine? Now, the second factor which influence the electrostatic force, uh, according to Augustine de Coulomb, he realized that the distance between the two charges matters. And he realized that it's an inverse relationship. So, second factor says the electrostatic force, all right, between any 2-point charges, any 2-point charges is inversely proportional. Okay, I hope that's the correct spelling. Is inversely proportional to the distance, or to the squared distance, right? Um, between the charges. Between the charges. So if we can come up with a relationship as well, we realize that F is inversely proportional to 1 over r squared. That is an inverse relationship, which means when we increase the distance, we are decreasing the force. And when we decrease the distance, we are increasing the force. So it's an inverse relationship, right? That we have there. So putting the two together, the two relationships, we'll come up with something like F is directly proportional to charge 1 multiplied by charge 2 and inversely proportional to the squared distance. Now, in science, we have got a way of removing the proportionality sign, right? And we can remove the proportionality sign by putting what we call the proportionality constant, which is K. So we can introduce a proportionality constant here, right? Proportionality constant, right? So we can introduce a proportionality constant, which is K, right? And the value of that constant is given and it doesn't change. So when we introduce the proportionality constant, which is K, we can get rid of the proportionality sign. So we are going to have a formula which says F is equals to the constant charge 1 multiplied by charge 2, everything over distance squared. So this is the formula that we use to calculate the electrostatic force between any two charges or between any two charged objects. I think it is very fair for me to label this a formula so that we won't have problems as we move together, where F represent the electrostatic force, right? The F represents the electrostatic force and it is also measured in newtons. And Q1, this is the magnitude of charge 1 and it is measured in coulombs. And then Q2, this represents charge 2, which is also measured in coulombs. And R is our between distance between the two charges, or between charge 1 and charge number 2. And our distance, definitely it has to be in meters, right? And then finally, our K, it is our constant, right? Uh, electrostatic constant. Let's just call it electrostatic constant. We can also call it Coulomb's constant. It's fine. Electrostatic constant. and the value is given. It's 9,0 times 10 to the power 9, and the unit is Newton per square meter per square coulomb. That is the constant. So whenever we're going to be doing our calculation, let us know that the Coulomb's constant is that value and it doesn't change. So before us, now before I move on to the next slide, we have the Coulomb's law in the form of a formula. So if ever they could ask you to state the Coulomb's law in terms of a formula, that is the Coulomb's law, or in symbols, that is the Coulomb's law. F is equals to K Q1 Q2 over R squared, right? But now we need the Coulomb's law in words. We need to derive the Coulomb's law in words from that particular relationship that is on our slide right away. Okay, so I'm going to write the Coulomb's law now. It is very important that we all know the Coulomb's law in words, because you are always requested to state Coulomb's law in exam. So I'm going to write it for you, Coulomb's law, and it must be underlined as well. Coulomb's law, let me underline it. Coulomb's law, it says the magnitude, it states that, remember the word magnitude means size in science. So the magnitude of the electrostatic force, magnitude of the electrostatic force, all right, between 2-point charges, 2-point charges, right, is directly proportional, is always directly proportional to the product, proportional to the product of the magnitudes of the charges, which means the magnitude of the charge matters, right? Product of the magnitudes of the charges, and inversely proportional, right? Inversely proportional to the square. Don't forget to square, when you do your calculations, to the square of the distance. Square of the distance between them. So I want to rewrite it as a formula again, so that we always relate to the two. So the formula is F, which is our electrostatic force, is equals to the electrostatic constant multiplied by charge 1 in Coulomb, multiplied by charge number 2 also in Coulomb, everything over distance squared in meters. So that is our Coulomb's law, and we are going to use this Coulomb's law to calculate the electrostatic force that exists between any 2-point charges. Remember, we said these are charges which are at rest, which are not moving. And as we do the calculation, don't forget to convert the units. Your units for charge must always be in coulombs. Your units for distance must always be in meters, so that your force can be in newtons. Right. Now, I'm going to do one example with you, right? And we calculate it together, and then we take it from there. Now, I'm going to put one example, but before I go to the example, what is it that I need to remind you guys? Okay, let's just put the basics together on the table here. Number one, we said these are supposed to be charges which are at a point, or which are supposed to be at rest, right? That's point number one. Then point number two, we said when we use this formula, We must make sure that we convert our units. For the charge, it must be coulomb. For the distance, it's supposed to be meters, so that the units for force is supposed to be newtons. Then finally, I said there are two factors which influence or which can affect the size or the magnitude of the electrostatic force, which is the force between two charges. And those factors are, number one, the magnitude of the charge. It's a direct relationship, which means the bigger the charge, the stronger the electrostatic force. And our charge is the independent variable, whereas the force is the dependent variable. Right. So the magnitude of the charge matters when it comes to the magnitude of the electrostatic force. Point number two, which affects electrostatic force, it is the distance between the two charges. So, and it's an inverse relationship, which means the bigger the distance between the two charges, the smaller the force. The smaller the distance, the bigger the force of attraction. So they exert greater influence on each other if they are too close to each other. So that's basically a summary of Coulomb's law. Now, what is left is for us to do an example on how to use that formula. And as we are going to use that formula, there is a tip that I want to give you, and I want to write it as NB. We must ignore the sign, right? Yes, we ignore the sign of the charges. All right. Whether you're dealing with positive or negative charges, we ignore the sign of the charges when we substitute in our values into the formula. When we substitute, right? When we substitute the magnitude of the charges into the formula, we ignore that. But we need those signs, or yeah, we need the sign of the charge at the end of the calculation. So we use the sign to determine. So when you get your answer for the electrostatic force now, we will use the sign to determine whether the force is repulsive or attractive. So let me put more flesh to that. Now, what I'm saying is when we substitute the charges into the formula, into the Coulomb's law, we ignore the sign whether the charge is negative or positive. We care less about that. We just substitute using the magnitudes. We insert everything into our calculator. We get the magnitude of the electrostatic force. Then we need to go back to the original charges and check. If they were like charges, then it means that electrostatic force is repulsive. If they were unlike charges, which means positive and negative, then it means that magnitude of electrostatic force has to be attractive, powerful. Now let's move on to the next slide, and I am going to do one example for you for now, and then we take a break. So allow me to write here example 1 under electrostatics or Coulomb's law. Right, I'm going to write it here. It says 2-point charges, um, 2-point charges, 2-point charges, right? Carrying charges, of plus 2 nanocoulomb and minus 5 nanocoulomb are 200 centimeters apart. Okay. What is the question now? Determine or calculate, right? Determine the magnitude, which means the size. Determine the magnitude of the force, which is the electrostatic force. Yeah? Determine the magnitude of the force between them. obviously, this is electrostatic force between them, and state, that's powerful, and state whether it is attractive or repulsive, and state whether it is attractive or repulsive. Powerful example there. Now, what we need to do now before we can embark into our calculation, probably we need to come up with a sketch of the arrangement of the charges here. We need to identify charge 1 and identify charge 2. We're going to use the order that they followed in the question. So I want to assume and I want to believe that plus 2 nanocoulomb is our charge 1. So I can put a dot there and I write charge 1, which is equals to plus 2 nanocoulomb, right? And I want to identify my second charge, which is charge 2, which is equals to minus 5 nanocoulomb. And the distance, right? The distance between the two, it is in centimeters and it's 200 centimeters, right? That's what we have and that's what we are dealing with at the moment. So we go back to the question, what is it that we are requested to do? They want us to determine the force. Now, in our syllabus, especially for grade 11, we have got one formula that we can use to determine this electrostatic force, and that is the Coulomb's law. Right. Now that I know, Kuri, this is electrostatic force, I now know that I must use the Coulomb's law. So I need to determine, I need to write my given data here. Please, whenever you do your calculation, it's very important that you state your given data to avoid unnecessary confusion as you do your calculation. So what are the values that I'm provided with? Let me start with the constant because it doesn't change, which is 9,0 times 10 to the power 9, right? What else am I given? I'm given charge 1. It is given nanocoulomb. We must convert nanocoulomb to coulombs. We multiply by 10 to the power negative 9. So instead of writing 2 nanocoulomb, it becomes 2 times 10 to the power negative 9. Now it's in coulomb. And then charge number 2 becomes 5 times 10 to the power minus 9, and it's coulomb. Distance, it's in centimeters. We must write it in meters. There are 100 centimeters in 1 meter, so you divide by 100 there. So that gives me 2 meters. So what is it that I'm looking for? I am looking for F. So that's where I am. Powerful. So I state the formula. Remember to write the formula as it is in the formula sheet so that you get that one free mark for the correct formula. F is equals to K Q1, Q2, everything over R squared. F is equals to 9,0 times 10 to the power 9. You close. Q1 is 2 is 2 Q1 is Q1 is Q1 is 2 times 10 to the power minus 9, and Q2 is 5 times 10 to the power minus 9. Right. Everything divided by 2 squared. So F is equals to. Now I need my calculator here. I need my calculator. I hope you are using a Casio calculator like mine, which can also use fractions. I open, I put 9 times 10 to the power 9. I close there, 9 times 10 to the power 9, right? I open bracket, and I've got 2 times 10 to the power negative 9, right? I close there. I open, right? I've got 5 times 10 to the power negative 9. I close everything over 2. I close, don't forget to square. Then I hit the button there. I'm getting 2,25 times 10 to the power minus 8. And this is newtons. Now, this is the magnitude. And guys, you can always use your calculator to verify this answer. Eh? You're allowed to do so. If mine is wrong, you can always calculate and get the correct one. My duty, my responsibility as your teacher, as your tutor is to assist you and guide you on how to get these answers. Right. So this is the magnitude. I've read get more marks. The last part, state whether it is attractive or repulsive. I need now to go back to the original question. There I am having a negative and a positive. So therefore, this is attractive because I'm dealing with a positive and a negative charge. So friends, this is example one, and I'm going to do example two for you in our second video. But for now, enjoy the introduction to electrostatic force and also enjoy the first example that I've given you. Then we meet again in our second lesson where I'm going to bring more examples on Coulomb's law, and then we take it from there. Thank you so much and take care. Edge Blush. Love you all.